All right, today we're doing chapter 6, section 4, linear inequalities in one variable. What does linear mean? Line, yeah. The first four letters of the word linear spells line. So linear equations are equations of lines. Linear inequalities are inequalities that are on the number line, because it says one variable. So it'll look something like this. There are three forms to represent inequalities. You have the set builder notation, interval notation, and graphical. Unlike linear equations, which have only one solution, linear inequalities have a range of solutions. This range of solutions are represented in sets. Whenever you see these squiggly brackets, those represent the sets. Those are inside the sets are all the elements that constitute the answers. Okay, solve that one. You know how to solve this. And then when you finish that, solve that one. Okay, so the first one. How do you when you say solve, if it has an equal sign, that means you have to isolate the variable. So we have to get rid of the non-variables. How do you get rid of the +3? -3. It's a process of opposites. So we have x, 5 minus 3 is 2. So the solution set is 2. When you solve inequalities, treat the inequality like an equal sign. Do the same thing. So we have to get rid of the 3. Five minus 3 is 2. Now, the solution set here, this is only one number. This one has an infinite amount of numbers. The solution set here everything from -infinity to 1. So any of these numbers inside this list is acceptable because it'll satisfy this condition. So, but this is pretty cumbersome to write. So that's why we have set builder notation that looks like this. This is the set builder notation. The way this is read, that squiggly line means the set of x. This little vertical line means such that and inside here is at least one condition such that x is less than 2. That's how it's read. The set of x such that x is less than 2. How would you write the set notation, set builder notation for that answer? Remember, what this says here is the set of, actually, I could put all x's such that. Because we've seen here, it's more than one number, it's a series of numbers. Since this only has one, I'd put the set of all x's such that x equals 2. That's how that one would look. And this becomes a lot of stuff to write. So that's the reason we just break down and write the conditional part. We just write this part nowadays. We don't do this whole thing here. We just put, okay, what is x? X is less than 2. So we call this set notation. That's set notation. It means set builder notation. So set notation, uses the inequality symbols. All right, let's look at the next type. These So we have these in set notation. What does this first one mean? You're a 50-50 shot. No. How do you read math statements? Left to right. So this number, it always points to the smaller one. So this is the less than symbol. This number is less than this number. So it means the next one is greater than. This number is greater than that number. So it points to the smaller, it opens up to the bigger. Think of an alligator eating a bigger piece of meat. How about the third one? Yeah, this one is less than or equal to. Then this one is greater than or equal to. So that's how we create our set notation. These inequalities match up with, if it's a strict inequality, not equals, then these are going to be represented by open circles. If they have a line underneath it, those are by brackets. I mean, closed circle. I'm sorry, closed circle. So if it can be equal to, then it's a closed circle. If it's an open circle, you can't use that last number. Or the less than, greater than are represented by parentheses, and the equal tos represent brackets. Which these here represent the interval notation. They use parentheses and brackets. Or any combination of them. So this one, from negative infinity to positive 2. How would I represent this as set notation? It's much easier if we look at the graphs of them. So in this first one, we have a line. 0 is somewhere in the middle. To the left, all the way to the arrow, how far does it go? To what number? Negative infinity. To the right is positive infinity. So what this one says, I start off at negative infinity, I go all the way to 2. It's a parenthesis. So that means I can use all of these numbers here. There's the number, all my answers have to be between negative infinity and 2. These are my x's. So x is to the left, it's less than 2. Because since all these numbers are less than 2, that's what it looks like. Both of these, honestly, all three of these mean that my answers, my data set, negative infinity, -1, 0, 1. It stops at 1. Why does it stop at 1? Can we use 2? Is 2 included? In other words, is my answer equal to 2? No. Equal to is either a closed circle or a bracket. These means I can go all the way up to, but I can't use that number. So I can go all the way up to, but I cannot use 2. So the biggest number I can use is 1. Remember, I said that parentheses and open circles mean the same thing. They're not included. So the number 2 is not included in your data set. Some books use this symbol notation, like our software, I think is use it. Some of them use this. They mean the same thing. So if you have a strict inequality, it's open circle or a parenthesis. If it's included equal to, it's closed circle or bracket. Now it's time for us to go through all the possibilities. There's a lot of them. So on your piece of paper, it helps if you get a blank piece of paper, because if you want a piece of paper, you can get some of these. But draw a vertical line all the way down. The left column will be set notation. The middle column will be interval notation. And the right column will be the graphical representation. So here's the first one. X is less than some number A. I'm going to use A instead of putting a number. A could be anything. It could be less than -5, it could be 100, it could be 1,000, it could be -1,000,000. Whenever you go from one type to another, it's always easier to see the picture first. So here's our number A. Since X is less than A, less than goes which direction? Left. So all the X's to the left to negative infinity. And I use either a parenthesis or an open circle. Either one, all depends on what system you're using. It's either a parenthesis or, but it has to open to the left. Now, the interval notation. Look at the both endpoints of your graph. It starts off at negative infinity, comma, goes all the way to A. At A, notice there's a parenthesis and there's no equal sign. So we cannot use A. We can never get to A because it's not equal to. And you can never get to infinity or negative infinity. So infinity and negative infinity are always parentheses. There's the first one. Let's look at this one. X is greater than A. So we have negative infinity there, positive infinity there. Since we only have A to worry about, we label A. Which direction is X going now? To the right. All the X's over here. Can you use A? So is it a parenthesis or a bracket? Parenthesis. And since it opens that way, it's left. Or again, it's easier. If the system lets you, you can use an open circle there because you can't, it's not equal to. So how do we do the interval? Look at where we shaded. The smaller number, comma, the larger number. You can never use infinity, so it's always parenthesis. Since A is not equal to, X is less than or equal to A. So less than shades to the left of A, going to negative infinity, but it's equal to. Since it's equal to, it's a bracket or a solid dot. Because now I can use the number A in my answer. That's what the bracket means. X can equal A or anything smaller than A. So again, look at the bottom two numbers of where it's shaded. It's from negative infinity to A. Infinity is always a parenthesis. Now, since I can use A, I put a bracket there. X is greater than or equal to A. So there's negative infinity, positive infinity, and here's our number A. If it's greater than, that means it goes to the right. And since it's equal to, then it's a bracket or a solid dot. Again, for the interval notation, take your beginning and end point. Parentheses always prints. Infinity is always in parentheses. Since A is equal to, I can put a bracket on. So far, so good. We have two more sets of 4 things to go through. What if X was between 2 numbers, A and B? So what this says is I have A here and B here. X is between these 2 guys. Those are all my X's. Do I put parenthesis or a bracket on A? Parenthesis because it's not equal to. Same thing with B. Or you could put open circles there on both of them. For the interval, look where your numbers start and look where they stop. Since they're both parentheses, that goes there. A is less than X is less than equal to B. So negative infinity, positive. Your graphs will always label negative infinity, positive infinity, because in case you get that way. So we have A and we have B. X is between there. You cannot equal A, so it's a parenthesis or an open circle. But B is equal to, so it's a bracket or a closed circle. The range goes from A to B. A is not included, B is included. A is less than equal to X is less than B. Negative infinity, positive infinity. There's A and there's B. X is between A and B, so I shade that part in. A is equal to, so it's a bracket or a solid dot. B is not included, so it's a parenthesis or an open dot. So the shading goes from A to B. Since it's equal to on A and not equal to on B. A is less than equal to X is less than equal to B. Negative infinity to positive infinity, A to B. Since they're both equal, X is between A and B, so that means they're brackets at both ends or solid dots. So the line goes from A to B, and they're both brackets because they're both included. All right, in these next four, I'm going to give you, it's easier if I give you the graphic part first, and we can talk about that. The four that were above, I gave you A and B, it's between there. What if now they go opposite of each other? So in this part, remember the shaded region is the X. So that one says X is less than A. Or X is greater than B. It's a lot easier if you try to write your answers. It's not necessary, but it's a lot easier if you put X on the left-hand side. Because if you put X on the left-hand side, the direction the arrow is pointing, that's the part you're shading. So from B to the right, from A is to the left. So it's much easier if you do it that way. Now the problem comes with the interval notation. This first shaded region, it goes from negative infinity, comma A. They're both parentheses. And then you have B, from B to infinity, and they're both parentheses. If you think back to chapter 2, we did the inequalities, we did the set notations for the truth tables. The or statement is represented by the union symbol. In interval notation, you have to put the U. In set notations, you have to write the word or, because they mean the same thing. X is less than equal to A, or X is greater than B. So this first one, from A, the line is going to the left from A. And A is included, so it's a bracket or a solid dot. From B, the line goes, the arrow is pointing to the right, so it goes to the right. And there's no equal sign, so it's parenthesis or an open circle. So look at the first one. We have negative infinity to A. Infinities are always parentheses. Since A is included, we've put a bracket. The second one is from B to infinity. B is not included, so it's parenthesis in that one. X is less than A, or X is greater than equal to B. We have A and B there. So this first one says X from A, the line goes to the left from A. So shade that part. From B, the line goes to the right. A does not have, it's not included, so it's a parenthesis. B is included, so it's a bracket. So negative infinity to A, and then from B to positive infinity. Infinities always have a parenthesis. A is not included, so it's a parenthesis. B is included, so it's a bracket with a union in the middle. And the one above there. You have to have a U in between there. X is less than A, or X is greater than equal to B. So negative infinity, A, B, positive. So from A, it goes to the left. From B, it goes to the right. They're both included, so they're brackets. Negative infinity to A, parenthesis, and A is a bracket since it's included. B to positive infinity, since B is included, it's a bracket with a union between them. Two more. So the graph of the first one. Negative infinity, positive infinity. There's A. So what symbol do I put on A? Because it's equal to. The only value X and equal is A, so I put a dot there. That's the reason we put dots on number lines. So what interval notation would I use? What's that? But yeah, so the smallest we can have is A, the largest we can have, and they're equal to, right? So the answer is just a bracket A. You're right. Because it's equal to. And the last one, since it cannot equal A, it's an open circle. That means it's everything else. Everything else except A. We could write it negative infinity to a, union a to positive infinity, but that's a lot of writing. What's a faster way we can write it? That one says I cannot use a. I can use any other number, but I cannot use a. Those are all the inequality ones. So you see, it's easier if no matter what you get, if you put it into a graph first, it's easier there to convert to the other two systems. All right. Any questions? Let's look at some examples. You're almost done. Right. Put it in the other two forms. Listen, always put it in graphics form first. And that's what we did in the last one. We put -5 and 3. We knew it had to be between there. So the x has to be between the -5 and 3. So in this one, the only number we have is -2. Now, is x bigger than or less than -2? Yeah, x is greater than. Because if you read it this way, x is greater than -2, or -2 is less than x. So since x is greater than -2, greater than goes to the right. Since there's no line underneath it, that means it's a parenthesis or an open circle. This is in set notation already, so I have to put it in interval notation. The interval notation always needs a beginning and an end. -2, infinity. Infinity is always a parenthesis. You can never get to it. And since we can't use -2, we put a parenthesis around it. Pretty easy. No. 3x plus 5 is less than or equal to 11. Give me the other two formats. All right. Again, treat it like an equal sign. Get the x's by itself. All the x's to one side. Get rid of the +5 by a -5. 5's cancel. 11 minus 5 is 6. Divide both sides by 3. X is less than equal to 6 divided by 3 is 2. So look at the graph of this. Here's the number 2. X is less than, because the arrow is going to the left. Since it's equal to, I have a bracket there. So I put my two numbers, negative infinity, comma 2, parentheses always on infinities. Since I can now equal to, it's a bracket. Right? Let's pick number 28. It says 1 over 2x is greater than 3. Okay, remember, treat the inequality like a equal sign, right? So remember, if you have fractions and an equal sign, step 1, find the LCD. What's the LCD in this case? 2. The only denominator we have is 2. Second step, multiply the LCD to each term. How many terms do we have in this equation? 2. This is a term, that's a term. A term is anything separated by a plus or minus or equal sign. So I put a 2 in front of this first one and a 2 in front of this next one. Step 3. Reduce, cancel. The whole purpose of us doing this is to get rid of fractions. So the 2 and the 2 cancel, leaving this side with just x. And now multiply. 2 times 3 is 6. Last step is solve for x. Those are always the 5 steps whenever you have fractions and an equal sign. We're always going to be using these 5 steps. So this is one of the answers. Put this in graphical form. Which direction does the line go? Yeah, since it's pointing to the right, we go from the right, from 6. All the way to infinity. Since there's no line, it's either a parenthesis or an open circle. Does either one. Take the beginning and the end. Infinity is always a parenthesis. Since 6 is not included, there we have it. Let's look at number 51. 3x plus 1 minus 5 is less than 2x plus 1. Okay. All right, what's the first thing you have to do? Order of operations says do what? Can we do anything inside the parentheses? We can't do anything inside it. X plus 1, you can't add them. So you have to get rid of them. 3 times x is 3x. Positive times positive is positive. 3 times 1, 3. That's 2x plus 1. Whenever you get rid of parentheses, always combine like terms. So on the left-hand side, we got rid of parentheses, so we combine these two. 3 minus 5. So 5 is bigger than 3. The answer is going to be negative, because that's negative. 5 minus 3 is 2. You have x's on both sides. Which one do you move? Always move the smaller to the larger. Since that's a positive 2, we subtract 2x to both sides. Move the x's before you move the non-x's. That's the most important thing. 3 minus 2 is 1. And positive 1. Because if you move the 2's first and everything, you could end up with a negative in front of your x, which is not going to give, it's not going to be difficult, but you may have a wrong answer. Since all the x's are here, we have to move all non-x's over there. So we have to get rid of the negative 2 by adding 2 to both sides. X 2 plus 1 is 3. So x is less than 3. That's the only number I have is 3. It's pointing to the left. So I shade to the left. There's no equal sign, so it's a parenthesis. Since here's my shaded area, I look at the beginning and the end numbers. I can never use infinity. Since 3 is not equal to, it's a parenthesis. All right. Let's look at number 55. X over 4 minus 3 over 2 is less than equal to x over 2 plus 1. Okay. Fractions and equal sign. What's the LCD? 4. The LCD can never be smaller than the largest number on the denominator. So in other words, 2 cannot be the LCD. It always has to be as big, if not bigger, than the largest number. Multiply the LCD to each term. So we have 4. This is the first term. This is the second term, third term, fourth term. X over 4. Just put 4 in front of each of those parentheses. You're multiplying. So you multiply each one. Reduce, cancel, eliminate the fractions. 4 goes into 4 once. 2 goes into 4 twice. 2 goes into 4 twice. So it's 1 times x gives me x. 2 times 3. 2 times x. And 4 times 1. Multiply to get rid of the parentheses. 2 times 3 is 6. 2 times x is 2x. 4 times 1 is 4. And solve for x. We have x's on both sides. Always move smaller to the larger. So I subtract 1x from both sides. Two minus 1 is 1. All the x's to one side. Get rid of the non-x's. Subtract 4. They're both negative, so the answer is negative. Add the numbers. 6 plus 4 is 10. This is the answer, but it looks different. So if we're going to move the x to the other side, flip the whole equation. So the arrow points to the 10, or the negative 10. So the arrow points to the negative 10. If you're going to flip it, flip everything. So our graph, only number we have is negative 10. We shade to the right. And it's an equal sign, so it's a bracket. So take the beginning number and the end number. All right, there's one more type of equation that we have to look at. They're called tripartites. We have 3 parts. What if our equation looked like number 63? Negative 11 is less than 2x minus 1 is less than equal to negative 5. Since we're solving for x, we only worry about what we do in the middle. Whatever we do in the middle, you do to both sides. So the first we have to get rid of is what? The negative 1. How? So we add 1 to everybody. Positive, 11 is bigger, so the answer is negative. 11 minus 1 is 10. Negative 5, positive 1, different signs. Take the sign of the larger and subtract the numbers. 5 minus 1 is 4. Get the x by itself, we have to do what? Divide everybody by 2. So it's negative 10 divided by 2 is 5, less than x, less than equal to negative 4 divided by 2 is 2. When endpoints of our graph are negative infinity, positive infinity, we have two numbers here, negative 5 and a negative 2. X is between there. Since you cannot use 5, there's no equal sign, you put a parenthesis. The 2 has a bracket, so it's equal sign. So we look at the end numbers, negative 5, negative 2. You cannot use negative 5, so it's a parenthesis. You can use equal to 2, so there you have it. That's the procedure. And that does it for the class. Yay!